Hello, everybody. Thank you very much for your patience. We have some technical difficulties, but I think we resolved most of this, so we can start the webinar. This webinar is, I'm Marina Timofeeva. I'm Climate Services Branch Chief in National Weather Service Headquarters. And this is climate series webinars. And today we have a very special guest, Rachel Jonassen. Rachel will present to us climate change risk assessment, user needs and decision support presentation. Rachel leads climate change programs of the Environmental and Energy Management Institute at the George Washington University and holds their joint appointment in the Engineering and Urban Sustainability programs. She has supported multiple federal agencies and private industries on strategic challenges surrounding greenhouse gas mitigation and climate change adaptation. She used to work at the National Science Foundation, and where she managed carbon cycle research program, and served as U.S. Global Change Research Program, where she was a lead author for the strategic plan for the U.S. Climate Change Science Program. As an academic researcher, she performed high-resolution stochastic simulation of climatic response on various greenhouse gases scenarios for nuclear waste, water resources, and biological impacts. Her work has been featured in 8 books, more than 70 professional papers, and 150 professional presentations. She currently focused on international interventions, supporting UN, World Bank, and Asia Development Bank, and serves on the multiple panels at the National Academies. Rachel, without further ado, I would like to transfer the microphone to you. Are you ready?
Already, yes. Thank you so much, Marina. Appreciate the introduction. Right. And very much appreciate the opportunity to make a presentation today, and especially to get some feedback. Apologize for the glitches earlier that's held us up, but I tend to use Firefox, and my browser didn't cooperate very well, so we're sort of improvising here. So I'm going to talk about, I am Rachel Jonassen from George Washington University. I'll talk about climate change risk assessment. I'm really not going, this is not a how-to. I'm not going to try to teach how to do climate change risk assessment. You folks probably have lots of experiences yourselves, but I'm going to talk about a little bit of what I see as some of the challenges of climate change risk assessment. Okay, so some of the challenges that I see, I'm going to first talk about Paris Agreement and what's called Paris Agreement alignment, and how that interacts with climate change risk assessments and some of the challenges that presents. The next thing, something near and dear to the heart of those who work in climate change, is the whole challenge of using climate change projections. So I'm going to talk about some of the issues associated with those projections. Something that we all are concerned about is reliability, and I want to talk about some aspects of reliability and some of the little tweaks and difficulties and workarounds that are maybe possible in assessing reliability of climate change projections and the results of the climate risk assessment. Obviously, risk is the center of a climate change risk assessment, so I'm going to talk a little bit about this, how risk might be estimated and some of the difficulties that presents, and then one of the alternatives in that is thinking in terms of vulnerability rather than risk, and the little change in approach that produces, and the new challenges to professionalism that leaves. I'll hopefully be able to give you some insights into some reliable global resources. Of course, there's lots of resources, especially NOAA resources, particularly focused within the United States, so there's an abundance of those, but globally, there are much fewer resources, and certainly fewer resources that we might consider reliable resources. So I'll talk about some of those, and then in the end, I want to talk about AI and some of the ways that I've been using AI in climate change risk assessments and some of the opportunities that I think AI will present for us as we move forward, although it's going to take a very large investment to get it to that point. So moving on then, let me first talk about so Paris alignment. The first issue with Paris alignment, first thing to keep in mind about this is that in an international sphere, a lot of the climate change risk assessments and the ones that I do are generally done in the context of the multilateral development banks. And the Asian Development Bank is one of those, and the Asian Development Bank is the one that I especially work with. And the multilateral development banks have developed a general approach to ensure Paris alignment of all of the efforts that they finance. And I illustrate that in icon in the upper right. There are these 6 building blocks as they label them. The second building block is related to adaptation criteria. And that's the one that I'll just illustrate here. There are 3 questions that are being asked in terms of adaptation. First, is the asset, and I'm paraphrasing here and to shorten things, is the asset at risk from climate change? Now, within the world of the Asian Development Bank, and I think in many places, climate change risk is really assessed as low, medium, or high, or some scale. So there's really no such thing as no risk from climate change, at least as the appraisals present. So what's really meant here is low risk. If it's low risk, then we can kind of ignore the issues and move on and say everything's fine. That's rarely the case that a project is at low risk from climate change. And so usually it's either medium or high risk. But of course that requires a climate change risk assessment to be done to be able to answer that. So the first question then is really asking for a climate change risk assessment to be done. Have adaptation options been identified? Yes, the climate change risk assessment will identify adaptation options, but this question is sort of a double-sided blade, if you will, because identifying the options is very different than applying the options. And I, as a scientist helping to develop the climate change risk assessment, can't assure that the adaptation options that we're recommending are going to be applied. And we can only say whether or not we've actually identified them and recommended them for use. The last part is really a very difficult one, and we'll return to this to sort of keep this one in mind. Is the project or asset or an expenditure or investment that's being financed consistent with the adaptation priorities of the country? Easy, relatively easy to figure out the adaptation priorities of the country. But it's also asking, is it consistent with the adaptation priorities of, say, the business sector that's involved in this, with the local areas that are being affected by it? And those are far more challenging to assess, certainly with somebody working from a distance. And that's one of the things, again, we'll return to take a look at the challenge of how do we figure out answers to questions like that. The next aspect of dealing with a climate change risk assessment is concerning the projections that are going to be used to make that assessment. Ideally, of course, in a climate change risk assessment, you'd like to entertain the whole range of possibilities for scenarios and develop some estimate of risk under the various scenarios. But ultimately, a decision has to be made as to what level of risk you're going to adjust for. And my approach and my recommendations for the climate change risk assessments I do is that we should choose the most extreme of all those scenarios, SSP 5, 8.5, if you're familiar with the terminology of the representative concentration pathways and shared socioeconomic pathways. And of course, we have generations of these. Here we're illustrating both CMIP 5 and CMIP 6 scenarios. as you can see, they don't diverge radically early in this, but by the time you get out to where most projections are being used for climate change risk assessment out into 2060 or beyond, the differences are pretty well known. Some would argue that we already know we're not on the SSP 5.8.5 pathway. I'm not sure that that's really the case. I think we have promises that are suggesting that, but in terms of actual observed emissions, we haven't demonstrated that. And for that, to demonstrate that, I cite a very recent publication actually from this month by Ugeli et al. In Science magazine, and they examined a whole bunch of different possibilities in terms of to what extent we believe the current policies and promises that are being made out in the future. Multiple cases where you believe maybe some of the high confidence net zero targets or all of the net zero targets and all of the policies that are being presented. But in general, the most conservative situation where you only accept the current policies give you a huge range of possible outcomes in terms of global emissions running out through the end of the century. And so with that huge range of possible emissions that are documentably plausible under current scenarios, that's why I would tend to stick with the RCP 5.8.5 scenario. Others would choose other scenarios, and that means we could have other results from a climate change risk assessment. And we also run the risk of scenario shopping, if you will, trying to figure things suggested, oh, you should use this scenario, that scenario, to make the job easier of those who are making the decisions and doing the funding. And there is no overall MDB guidance on choice of scenarios and no clear scientifically credible statement of why a single scenario is better than another scenario. So it's very much professional judgment on these things. Moving on then to the next challenge that I see is dealing with the issue of reliability. Here I'm just illustrating the standard IPCC terminology that's used in sort of ideas of how reliability might be assessed by a user community. And as you see, the reliability estimates sort of the shades of reliability that go across, going from lower left to upper right, as we have more and more evidence on the x-axis and greater agreement between that evidence shown on the y-axis. Then they work relatively well for the IPCC to apply for its assessment reports, but it's very challenging to apply to a climate change risk assessment. Thinking about the definition of evidence that they apply, you should consider the type of evidence, the amount of evidence, the quality of evidence, and the consistency of evidence. And all of those things have their own limitations. The type of evidence for most of us is GCM results. The evidence quality might be considered robust for many GCMs, but I don't think that's necessarily uniformly the case. And so there's a lot of professional judgment and a lot of need for exposure to the scientific literature to be able to assess for particular applications in particular countries for particular problems how reliable a certain GCM may be. IPCC in general has recommended a multi-module approach using, earlier they recommend use as many different GCM as possible for a given scenario. And that introduces a lot of challenge in terms of assessing the quality of the evidence and consistency, amount, and type for these. So there are lots of challenges with applying this kind of metric of reliability in a isolated setting for specific projects then. I do list here, and thinking about reliability then, from my own experience, I list here, maybe for your own interest and for you may be interested in examining different sources of reliable data in terms of scenarios and other projection information. The IPCC Climate Atlas is a relatively new addition to the field, and coming under the aegis of IPCC, it sort of has that imprimatur. It's interesting also in that the IPCC, unique amongst all of the sources, does implement the new recommendations from AR6 Working Group 1, which, if you followed this over the last 10 years, IPCC had been saying that there was no evidence, no reason to believe that any model was better than another model, that it was the ideal is to use all the models that are available and to weight them equally. However, with the advent of the CMIP6 modeling, with the latest generation of models, the Earth systems models, one of the things that the CMIP6 examination noted is that we have what's termed affectionately the hot model problem. So some models are simply coming in much warmer and warming much faster than other models. It turns out that those models in general don't do so well with the historical period. And so in response to this, the IPCC has had to drop its recommendation that all models are as good as one another, and actually is now recommending a much more nuanced examination of which models should be used. Also, because of this difference in warming rates for the models, they're also suggesting that rather than using a standard scenario where you'd pick a time period to examine the amount of warming, they're suggesting you pick a level of warming, and this is global warming then. So they've introduced this notion of global warming levels. The IPCC Climate Atlas is the only available tool that I'm familiar with that actually allows a researcher to implement those global warming levels ideas when performing their analyses, say, for a climate change risk assessment. So I strongly recommend you becoming familiar with the IPCC Climate Atlas. The World Bank Climate Change Knowledge Portal is another very well-supported resource. It has not yet implemented the global warming levels approach, but it's quickly being updated, especially with the new leadership at the World Bank, definitely demonstrating that there are a lot of improvements and additions that can be available. So it's a very, very flexible and useful resource. The other ones I'm not going to delve into in interest of getting through in a reasonable amount of time, but they're listed here, and you'll be able to refer back to these slides and explore these at your leisure then. I do want to illustrate here a more complicated result in terms of reliability with regard to those GCMs. So I'm illustrating in the left a model solution from the Climate Change Knowledge Portal of the World Bank. I was doing, actually in the midst of doing an analysis in India for a group of hospitals that are being proposed in northern India. The projection on the left is illustrating how the warm spell duration index, a measure of heat events, long extended heat events, how that will change over time in the future. And I'm just illustrating that out to 2060 in the left-hand diagram. But a more full analysis of the results of the model itself, instead of just limiting to the period of interest and looking back at the historical record, shows this very, very strange initialization problem with that. I have not run into this issue with any other variable that's being used in the World Bank Climate Change Knowledge Portal. I want to emphasize that. But in this particular case, one would have to really challenge the utility of it. If it's strictly an initialization problem because of the formula that's used to calculate the warm spill duration index, which is really a deviation from the historical record, it would be understood that the numbers for the historical record wouldn't make sense. However, if you look on the right-hand side, the results in sort of aqua in the lower part of the diagram, you see them wildly oscillating and the oscillations growing in magnitude as you get closer to the time 2021, and that, excuse me, 2100, excuse me. That's definitely some suggestion that there's some modeling problems here beyond, probably beyond the definition of the warm spell duration index. And so the lesson here that I would want to bring home is that one really has to spend quite a bit of time and effort examining the record that's involved in the projections that you're applying in order to really assess the reliability of these things. And in some cases, you simply conclude that they're not reliable enough for you to use within your assessments. Moving on to another topic in climate change risk assessment, sort of at the heart of climate change risk assessment is the notion of risk. And I'm illustrating here the classical definition of risk, where risk is the product of likelihood times consequence. And in the simplest example, maybe the one might imagine, I'm ranking likelihood on the left-hand side scale of low, medium, and high, 1, 2, 3, just assigning numerals to those. And the consequence scale on the x-axis, low, medium, and high. And then the product of those is shown in the matrix. And then the higher numbers, like 9, is just assigned as saying that's high. And then the yellow ones are indicating medium and the other ones low. These assessments, even though quite standard and quite well applied in the risk assessment community, and certainly pioneered by groups like NASA for their risk assessments, there's no actual meaning to low, medium, and high. For example, we couldn't conclude that because high is number 3, that it's 3 times as great a consequence as the consequence of low, or that medium is twice the consequence of low, and so on. So these are nominal scale numerals that are being applied. They're not, the intervals between them don't have meaning. They don't reach ratio scale. So what I would suggest then is the mathematics of risk assessment are yet to be made available and revealed to us. So these numerals that are assigned to risk have some severe limitations in terms of interpretation of those. So there's an alternative that's been taken up by the climate change community, and this is again guided by the IPCC, in thinking about risk in terms of vulnerability. And that vulnerability has 3 components: exposure, sensitivity, and adaptive capacity. And I illustrate it here because this is sort of the way easiest to think about. Sensitivity, the house made of straw, the house made of sticks, the house made of bricks, so more and more able to resist the force at work or the hazard there. So less sensitive to the climate change hazard that's being presented by the big bad wolf. All of them are equally exposed to that risk, but because of the differences in sensitivity, then you have a different overall level of vulnerability. So then how do we convert that into some sort of meaningful scale using the same sort of methodology? This is methodology straight from the World Road Association, the way they're recommending their climate change adaptation framework for the application to roads. Notice that they have a different numerical scale on the left-hand side, the vertical axis, in terms of the sensitivity rating, where it goes by increments of 2, whereas the scale across the x-axis, which is exposure, negligible, unlikely, possible, likely, almost certain, that's just incremented by 1. And then again, you have the product of those is the overall vulnerability index. Again, no special meaning to, is 36 times more than 1? No, you can't make conclusions like that. So that, again, the mathematics here are not maybe developed to the satisfaction of a mathematician, but in terms of a pragmatic tool, it is being used, and this is the one being recommended by relatively reliable organizations like the World Road Association. All right, so now I've illustrated some of the challenges of climate change risk assessment. I just want to talk for a couple of minutes about some AI tools and some of the ways that they may be useful. And I'm not going to delve into the AI tools. I don't think we have enough time to go into those, but I can talk a little bit about some of the things that they provide. ChatGPT, probably most of you have had experience playing around with ChatGPT. Very interesting tool to play with, but whether or not it's a research tool, I would question seriously. One of the problems with ChatGPT is that it's apparently unable to tell you where it gets its information. And when it does tell you where it gets its information, my experience is it's invariably misleading you and just plain wrong. It's not giving you actual pointing to real sources. And that's why I tend to use other AI tools, especially things like Perplexity AI. And that has a demonstrably really excellent ability to link to real literature and high quality literature and do a great summary of it. Elicit is very interesting in terms of characterizing research methodologies that are applied to research problems and drawing from the research literature. Cite is very good at supporting and contrasting evidence, learning whether or not the references that are being used as part of evidence have criticisms of those, and evaluating the supporting and contrasting history of journals, organizations, and funders. So lots of good information. And Consensus can accept research questions and find relevant answers within research papers and synthesize the results and give you good metrics about how useful those things are. So some tools. Now, why would we want to use these tools? Let me just illustrate real examples of CRAs. These are some of the CRAs that I've been involved in over the recent months and years. I'm just picking one, for example, in Bangladesh, looking at photovoltaic cells. That was an individual solar farm being considered, but it happens to be right on the banks of the Ganges River. And so if I'm going to assess the risk of floods for that solar farm, I've got to make an assessment of what's going to happen in the drainage basin of the Ganges, which of course includes part of the Himalayas. And so we need to delve into the literature in terms of what the research community is saying about that. So that kind of thing takes an awful lot of research. And so those kinds of tools, especially things that I mentioned like Perplexity AI, can quickly draw upon that literature and point you to literature that is worth examining to really try to get an assessment of what what's happening that can affect the flood, in this particular case, the flood risk. But the Uzbekistan photovoltaic project that I mentioned here involved 3 different solar farms in 3 different parts of the country, so very different risks involved there. But the risk assessment needed to be done in the same period of time. So here we are speeding things up and trying to move into doing things more quickly, and of course always trying to do them better. And then over here, I'm going to illustrate with this one in the Philippines, an energy project which involves all of the Philippines. An energy project might be done anywhere in the Philippines, and we need to do an advanced climate risk assessment without knowing where in the Philippines the project's going to be done or what kind of projects it's going to be. And so this gives you an idea of the scale of the issues that we're dealing with. And if we just stop for a second and think about how we all know how quickly we need to change the global energy system to a renewable energy system, then we realize how many thousands and tens of thousands of these assessments need to be done really quickly and at low expense if we're going to be able to move this thing forward. And this is one of the reasons why I think we probably need to consider intimately drawing in artificial intelligence to help us with our climate risk assessments and anything that can expedite and help the quality of the product that you're going to produce in terms of helping organizations and entities to minimize the climate change risk to the projects they're going to put in place, because it's not going to do anybody any good to build an energy project in the Philippines if the next typhoon is going to wipe it out and we have to start all over again. So that's kind of one of the motivations I think that are really important. The other aspect is just the sheer scale of a climate change risk assessment. here I'm listing 16 out of the many things that need to be considered in a climate change risk assessment. And as you saw maybe in the other map that I just showed, sometimes it's about energy, sometimes it's about hospitals, sometimes it's about e-bus transport systems, and so on. So the topics of expertise and the sectors involved are so very, very different. So it's really important to be able to bring in a whole lot of expertise and tap into the knowledge banks of many different disciplines in a very efficient and quick method to be able to put these things together and maintain the reliability and confidence in our results that we need to have in those. And then the last thing I'm going to just mention is again, the range of expertise that are involved in these climate change risk assessments. Every one of these disciplines that I list here and others has to be drawn into it, to say nothing of the sector-specific knowledge for each thing, like whether it's a hospital or whether it's buses in a transport system or whether it's an energy system or whether it's agricultural systems and so on. So the range of expertise that's required then is also so large that I think when you as professionals, and a lot of you are in that area of really user needs and decision support tools, I strongly recommend that we all be thinking about how we're going to take hold of those AI tools that are coming out and develop them in such a way that we can apply them to the problems we're encountering in climate. And this climate change risk assessment is just one of those then. And so with that, I hope I haven't taken too much time that takes away from the questions, but I really look forward to your questions and turn it back to you, Jenna, for any comments.
Yeah, thanks, Rachel, so much. Does anyone have any questions? You can submit them through the chat box. I don't see any right now, but we can take a minute or two. Marina, I see you came on mic. Do you have a question?
Yes, Rachel, thank you very much, first of all, for the great presentation. Could you please go to the 2 slides before the last one? One before? This one. Could you please comment, where do you see on this list NOAA could provide the biggest value in the process of risk assessment? For example, information on number 6, current climate, is probably the one. Number 5, hazard of interest. But maybe you see something else, that I'm missing.
Yes, thank you, Marina. Yeah, I mean, with NOAA's vast data sets that are available, and certainly, as an example, I very much rely on the hurricane and extratropical storm trajectory information that's available for NOAA. So, that kind of information, making it available and ensuring that it's available on a global basis is extremely valuable. So I think there's a lot to offer in that way. And I think in that in terms of new things, maybe making them more obvious to blind people like myself, but helping the user to understand, again, the uncertainties involved in use of this information, and again, in a user-friendly way. And I point back to the IPCC website and the World Bank Climate Change Knowledge Portal as models of sort of user-friendly ways of presenting information. Both of those really do emphasize a lot in terms of those uncertainty tools that are very useful. So I think, helping with that, I mean, obviously, NOAA writ large, you got the Geophysical Fluid Dynamics Lab, obviously very much involved in the climate projections. And so Number 8, the projections of climate change hazards. Again, helping to make that information available in a user-friendly way, maybe, again, modeling it on some of the tools that are available now and the user interfaces that are available. I would suggest that would be another area where NOAA writ large could be helpful.
So, Jenna, do we have questions? Because I have a follow-up.
No, not yet.
Okay, then my follow-up, Rachel, you mentioned uncertainty, and thank you very much for doing this. Is, from your experience, what are the good, best practices in communicating uncertainty? Because is there some special indices that are helping, or is there just because from your experience with the user community, I think this is, you probably have some ideas.
Yes. I really struggle myself to really try to grasp the depth of what, especially IPCC, has been trying to tell us all about uncertainty. And so I really go to them in terms of best practices and recommendations. And you're probably aware that for the CMIPS and the AR6 process, IPCC, as it's done in the past, has put out special guidance notes to authors. One very interesting one is a guidance note on the use of the terminology risk, just using the term risk and when it's appropriate to apply and when it's not. And it's really quite enlightening to read through that particular source. So I think I definitely have to defer to the IPCC and its thinking on risk. I mean, and the way to convey that. So I really strongly recommend it to a user in general to really dig into that. In terms of how you present that in a user-friendly way, I would not accuse the IPCC in that particular document of stressing user-friendly, because it was really intended for the author community. So some pretty well trained and professional folks who are going through this. So I'm not sure that I have too many examples I can point to in terms of really good tools for presenting that. Again, I think the World Bank Climate Change Knowledge Portal is a very good tool, because it makes not just the sort of the raw projection information available, but it presents, provides and makes available to you things like, confidence intervals and multiple confidence intervals that you can select for yourself. It allows you to display it in the information you're getting in maybe half a dozen standard kinds of presentation formats, which are very, very useful. So I think, first and foremost, in terms of a user-friendly interface, I would point again to the World Bank Knowledge Portal.
Thank you, Rachel. Jenna, back to you.
Yep, I'm not seeing any other questions that are coming through. But I will mention that we do record, we did have several registrants that didn't make it. So what we do is we record them, Rachel, and post it to our seminars page, and I'll send that out to the chat box right now. So that's where we will post it in the next couple of days. And then our next upcoming webinar will be at either the end of July or early August. We're still kind of nailing that down, and we will be announcing that as soon as we have that information set. But thank you again, Rachel, so much. And Marina, did you want to have parting thoughts?
Nothing from me in terms of parting thoughts, but very much appreciation to Rachel for very rich information that you provided. You know, I probably will follow up with you, Rachel, on the links to these different tools that you shared. So we will not have any ambiguity in understanding, but I think it is something that we need to examine very closely. Thank you again for a very nice presentation, Rachel.
Yeah, Marina, if we want to share those links, we can also put it with the webinar that we post, the recording.
This would be great.
Okay. All right. Well, thank you again, Rachel, and have a great day, everyone. I'm going to end the webinar now, and we will post the recording in the next couple of days, and we will send out. Oh, wait a minute. I just saw a question come through. Do you mind, Rachel, if you take the question?
I'm happy to take a question. Sure, I'm still here.
The question is there anyone who has quantified the probability of the various SSPs?
There is literature on estimates of probability. You know, if I have a link, or maybe I can provide that to you, Jenna, to send a couple of articles related to that I could recommend for reading. I think it's somewhat controversial to do that. Certainly in the past, IPCC has recommended against thinking that you could even do that sort of thing and put relative probabilities, since of course they depend so much on future policy. But the article that I cited and illustrated in the second, well, I know maybe the fourth slide, is an example of something close to, I think, what you're thinking about, because it is providing distributional information in terms of likelihood of various ranges of emissions, and obviously that leads then to concentrations and at least fairly close linear relationship with global temperature change.
Okay, yeah, and if you have links or any references to send me, we can always post them along with your recorded slides. So
I'll make a note to send a couple of links for references along with the other links that I'll be sending off to you, Jenna.
Okay, super. All right, thank you so much. Sorry about that, but there are no other follow-up questions. So thank you again, Rachel, so much. And again, we'll be posting this recording in the next couple of days, and I'll send out an announcement. So have a great day, everyone. Thank you so much.
Thanks, Jenna. Thanks, Rita. Bye-bye.
Bye, guys.